welcome. Quick question. Who of you are doing anything on Kubernetes? That means deploying, either developing, deploying, or operating. All right, what about OpenShift? Okay, now I want to see who is running on some of the cloud vendors. EKS, who has tried EKS, so Amazon's version? What's the feedback? That's great. Is anybody from AWS in here? No, thank you for releasing 1.13 last week. EKS is now 1.13, finally fixing a major issue that we ran into with our work recently. What about GKE? Who is running on GKE? Google? Here we go, you want to watch out. They're running on your competitor's platform. Anybody's doing anything on PKS, so Pivotal's service? Has anybody looked into that? No? AKS? Don't leave. It's getting better. All right. Or maybe you just saw the title and you figured out you're actually in the wrong place. All right. So today my talk is called Shipping Code Like a Captain. And I use the Keptn logo. So what is Keptn? Keptn is a new open source framework that we are building right now. With we mean the open source community, but right now it's heavily curated by some engineers at Dynatrace. So that's the company I also work for. The reason why we built it, I'll tell you in a second. What it does, I also tell you in a second. The idea is that we want to automate continuous delivery, but also make operations much easier. So we can all focus on code and pushing out new content. All right, so the first thing, before we get started, what I have prepared for you, I have installed a GKE cluster. I tried to do it on EKS, I promise. But I had to wait for 1.13. It just came out last week, so I still stick with GKE. I've also, in this cluster, installed Dynatrace for monitoring. Now, Keptn works with any monitoring tool. You will see later on some examples where we use Prometheus, and we're actually working with all the other monitoring vendors, whether it's in New Relic and AppDynamics, SignalFX, I think they're here too. We invite them all to actually implement an integration with Keptn, because what we do with Keptn is very heavily relying on monitoring data. So we can make decisions whether we want to push something forward, yes or no. All right, what's the other thing I did? Because you can also actually follow all of this, I just simply followed the instructions on the Keptn's website. So keptn.sh/docs. I downloaded the Keptn CLI. I also created a GitHub org, because right now what Keptn does, it stores all the configuration elements in GitHub. We're currently working with a team in Germany, one of our customers. They are implementing this for GitLabs, because they're using GitLabs. We have a team in Detroit that are also implementing the same configuration management or GitOps integration for Bitbucket. And I'm sure there's others out there. So Keptn will be able to store and read any type of configuration from any GitOps provider. And right now we have GitHub. What else did I do? It's really that easy. Once I have my GitHub org and I've downloaded and installed my CLI, I just say Keptn install. Keptn will install. What it will install, I'll show in a second. Then I have to configure Keptn to tell Keptn, hey, this is actually my GitHub repo that I want to use, where you can store all of your configuration data, because we follow the GitOps approach. So I give it obviously my username and my token. That's not my real token, as you can probably guess. And then the last thing I need to do in order for Keptn to work, so what does Keptn do? Keptn allows me to push continuously services that belong to a bigger project through different stages, through a pipeline into production. And it also automates the way for me to deal with problems in production. That's why the first thing you need to do with Keptn, let's see if this actually works. Here we go. Keptn create project. So I called it Keptn sample. And then I give it a Shipyard file. We will explore the Shipyard file in a second, but this is basically where I explain or tell Keptn that I want to have 2 stages, 3 stages, 5 stages in my pipeline. And the other thing that I have in the end is Keptn onboard service, where I basically say, hey, Keptn, one of the projects is my simple Node.js service. And then I can also add additional your own custom values, your deployment specifications, your service YAML files. So you can do whatever you want, basically customized, and then everything will be stored in Git. And just to show you that this is really all true, right? So let's see what we have here. Let me zoom in a little, because I'm pretty sure you don't like it that small. Dum, da, da, dum. All right. So I have kubectl, and then I do get pods in keptn. So keptn is installed, and hopefully the Wi-Fi is still with me. Here we go. So after you install keptn, when I did the keptn install, it is creating a keptn namespace. It is also, keptn is using namespaces. Keptn is using right now Knative as a serverless framework. Has anybody played with Knative? Has anybody heard about Knative? Here we go. It's an 0.x release. We are working very closely with them. I think we're one of the early adopters. They're a really great team to work with. It works for us, but we're still kind of making it round, let's say it that way. Also, what you see in there is we have Istio. So has anybody played with Istio? Yeah. We are using Istio right now for the purpose of supporting blue-green deployments, canaries, and basically for traffic routing, right? So that's what we do. So this is what I have on my cluster. What else do I have in here? Let me double check. Where's my mouse? The other browser window. Where's my other browser window? Here we go. So I basically really just followed my installation instructions on the keptn website, right? So if you install keptn, that's really all I did. There are ways already to install keptn on non-GKE. As I said earlier, with EKS, this should be hopefully officially available next week after we did our final testing with 1.13. We're currently installing keptn with 2 of our customers on-premise Kubernetes, and we are getting the installation instructions on there as well. And our OpenShift support is coming by the end of the week, and also AKS is coming in the next couple of days. And then the others follow suit that are missing. The PKS is still missing, but the rest is all there. Okay. So this is what I've installed. Remember, I also told you about my GitHub organization. So I called it Grabner, that's my name, keptn sample. So that's the org that I created. And after saying keptn create project, it created that keptn sample for me. And what it did in here, it placed the so-called shipyard file. Remember earlier, I basically showed you in the installation instructions. Let me make this a little bigger. In the installation instructions from keptn, you need to tell keptn, do you want to have just a production environment? Do you have a pre-prod and a prod? Do you have a dev stage production? You can basically define your individual stages. What you also specify in that shipyard file is your deployment strategy, whether it's a direct deployment, a shadow deployment, a blue-green, a canary deployment. What else do we have? A dark deployment, so we support different deployment models. And keptn will automatically take care of me for that. The only thing I need to give keptn is an artifact, a container, and then keptn will take it, will automatically create the Helm charts, will automatically configure Istio, will automatically make sure that this artifact gets deployed into each individual stage. Now, not in every stage. It starts typically, in my case, I have a staging stage and then production. It will start deploying it in staging, and then it will execute a test strategy. So then keptn will reach out to the tools that can do testing. It's all an event-driven model, and says, I need somebody to run performance tests against this deployed artifact in this stage. And after the tests are done, keptn will look at all the monitoring data and then decide, based on another config file, whether it's a good deployment or a bad deployment. This is what we call Potometer service. And I will come to this in a second. So, but this is the shipyard file. What keptn also did, as I said, not only did it create that GitHub repo, it also created the 2 branches. So here's my staging branch. And in staging, this is where we have automatically been, well, keptn was gracious enough to automatically generate the Helm charts, right? Here we go, where's the values? So it automatically created my YAML files, my necessary files, and keptn later on will also automatically update the YAML files in case I push through a new version. So I want you to keep an eye on this one, where it says right now, version 1.0 is deployed. This is the version of my sample lab that I have deployed, and this will later on automatically be updated. Okay, what did I miss? My keptn org is here. My keptn sample, this is there with staging and production. Oh yeah, the last thing you need to do is you need to onboard services. So it's a very simple example. It's a simple node service, so it's only one microservice that I onboarded. However, as you can see here, there's different subfolders that keptn assumes are there. For instance, there is a perfspec folder. The perfspec folder defines what we call a perfspec file, where I can specify after an artifact has been deployed, I want keptn to reach out to the monitoring tools. We support right now Dynatrace and Prometheus. And as I said earlier, we're working with other vendors to also build implementations. But here I can basically say, hey, keptn, go off after the tests are run, look at, let's say, response time, and then perform either a threshold grading, where you can specify static thresholds if you have static SLAs, but you can also specify and say, please compare with the previous good build and give it a certain confidence interval. Right? You can basically specify what to look at in order to figure out how good or bad a deployment is. And you can see here metrics core. The whole idea is you can have as many metrics as you want. And this is actually not only limited to monitoring tools. We have customers and users that also pull in data from their security check tools, from their functional test tools. So they pull in all the data and then they say, if I have all the evidence, normally as a human, I would look at this metric and say, good. I look at this metric, nah, not so good. I look at this metric, so la la. And then basically as a human, I would look at it and I say, what is my feeling? Is this a good build or a bad build? And that's the same thing here. So you can basically specify the thresholds, for instance, and then a metric score. Metric score means later on, when keptn is scoring that artifact, it will either give 50 points if this metric is below warning. It will give 0 points if I'm exceeding the severe threshold, and it will give me half of the points if I'm between warning and severe. So I can have as many metrics as I want, which brings me to the end where it says, what's my objective? My objective is if I'm evaluating a deployment and I get more than 90 points, I want keptn to automatically deploy this and promote it to the next stage. If it's between pass and warning, I want the human being to look at the results because it's kind of a gray zone. And if it's below warning, it means it's not a good build. Okay? All right. So this was a quick explanation, actually, what I had in what actually happened behind the scenes here. And there's also a video that I recorded that shows also the steps as well. So I want to actually show you a little bit now what happened behind the scenes in Kubernetes. So I have an app, a sample app, my simple node service that you've seen on GitHub earlier. What I actually have done, I have built 4 different versions of that app. Build number 1, and excuse my color scheme, I'm not good in colors, but I picked some strange colors and my boss is always giving me shit about it. Hopefully you're colorblind, then it doesn't matter. And if not, you probably will be colorblind after this talk because you see a lot of colors that don't match. So I have build number 1, and the way I actually tell keptn about my new artifact is I say, keptn, I have a new artifact, and it is this particular, Docker. In this case, it's a Docker Hub reference. It could be any Docker registry. What keptn does, it will take it. It will reach out to whatever tool you have told keptn to use for deploying, and it will then deploy it into the first stage. In my case, it's going to be, I know it's a little hard to see here, but it's going to be the staging stage. This is my very bad sample app. But actually, if I double click, I think it's a little bigger. You can see the URL, simple node service.staging. So it's deployed in staging. It will deploy it. It will run tests. And then it will enforce what we call the quality gates. And for that, it is using Potometer. So Potometer is another library that is actually reading that config file that I showed you earlier with the metrics. And it basically said, after the tests are executed, let's look at all the metrics and let's sum up the score. And if the score in this case is 90, remember, is above the threshold, That means it's good, it gets a check mark, and it will be automatically promoted into the next stage, which would be production. So this is build number 1. And let me double check if I have build number 1 really running, because I do have somewhere in my browsers 2 frames. Here we go. So this is, I'm neither good in UI design, neither good in HTML. So this is just a static HTML page with 2 iframes that is loading on the left side. My staging environment was currently deployed in staging, and on the right, this is what's running in production, and it refreshes it every 5 seconds, I believe. So this is just proof that my app is currently running. Now what I'm doing, I want to do what's actually in my slides. In my slides, as a next example, I have version number 2. So I have version number 2 already on Docker Hub, and the only thing I need to say is keptn new artifact sample service 2.0. And what it should do, it should deploy it, and then it should execute the tests. This will take a while, so I'm running it. And I'm actually using something to show you that this is possible with any other tools, that you can actually integrate keptn with your existing CI/CD tool. Because people sometimes ask us, so why did you build keptn? We already have Jenkins. We use it for deployment. We already have GitLabs. We already have Argo CD. And I said, it's perfectly fine. You can use whatever you have, but there are certain use cases in keptn, especially later on when it comes to deploying it into production and also keeping it in production and doing self-healing. Maybe you want to use keptn for that. So my use case now is, I'm actually showing you that in case I have a new build that comes out of Jenkins, I can simply also use Jenkins to tell keptn there's a new artifact available. And I built a very simple pipeline that is basically just making a REST call to the keptn's API, right? And if you look closely, what do I have here? I basically say, this is my GitHub org. Hey, keptn, in this keptn project, I have for this service a new version available in 2.0. Click on build, and off it goes. And off it goes means what should happen. It will deploy it into staging. It will then execute the tests. Now keptn itself doesn't execute tests. It will initially, internally create an event, a Knative event, which will trigger whatever microservice or serverless service is registered with keptn that can handle test execution. And then this test service will get all the information. It will say, please run your performance tests against this build. And by the way, here's your config repo. And in the config repo, you have your subfolder where your tests are stored. So if I look at my config repo, right, I showed you the perfspec folder earlier. But for instance, here, I'm using JMeter right now. Here's a JMeter subfolder where I have different tests. Currently, we have another testing company, Neoload. They are, or Neotis, they are building an integration with a Neoload, where you can then also use Neoload. And I encourage the community to obviously build other integrations as well. How to build custom services is very easy. We have a documentation for that as well. All right. I want to show you one other cool thing, and this is this here. All right, so what do I have here? I have I guess you know what this is. What is this? Slack. But I have a special Slack bot. I have the keptn Slack bot. So you can see here I ran some tests today, and I want to keep this open, and hopefully every time keptn is internally triggering an event, like, hey, there's a new artifact available, then keptn check Sparrow will tell me there's a new artifact available. It's like my keptn's log. And we also have a keptn's log and a bridge where you can actually look at the log. So these are all components from keptn. And I want to keep this open. And I should see, once keptn has received that event, once it's deploying it, I should see events popping up here. So I'll keep this open in the back end until it's coming. Hopefully it's popping up. So I deploy build number 2. Now build number 2, I built something in. First of all, not only the background color is ugly with orange, but build number 2 also has a performance problem built in. So after the tests execute, keptn will do the evaluation, and it will only get a score of 10, and it will basically say this is not a good build. And it will not promote it into prod. As time allows, we have 27 minutes left. I'll then also try to deploy build number 3. Build number 3 has another background color. Good news with build number 3 is it has the performance problem fixed. So now we have 95 points, which means it will automatically deploy it into production. And hopefully we'll get to build number 4 as well. Build number 4, a new artifact will be deployed in staging. It actually receives 100 points. It's awesome. It will go into production. But I'm sure you have had this in the past. You had a new build and it succeeded all the tests, but then something happened in production. So that's where we look at monitoring, and if the monitoring tool is telling keptn something is wrong, then it sends an event to keptn, and keptn will then trigger the remediation. And in my case, the remediation will be a rollback. Okay? So this is kind of the story of what keptn is now doing in the background. It's doing it with build number 2 now, and hopefully later 3 and 4. I want to pause here for a second. Does this make sense? Yeah? Okay. I also want to tell you, keptn is currently still in its baby phase. It's its infancy. Version 0.2.2 is out there right now. 0.3 will be released either by the end of the week or next week, which will then support OpenShift, as I said. It will also include a couple of new services that come with keptn. And we have a long, huge roadmap that we want to build. I invite, obviously, everyone to contribute and give us feedback. Everything is on Git, so just, and we're also on Slack, and I'll give you the Slack channel in a second. So this is the use case. Now, first of all, while this is running in the back, and let me actually see. Here we go. Actually, it didn't. Sometimes, I'm not sure, sometimes I get the notifications in Slack in Windows on the bottom, sometimes I don't. But you can see here now that at 1:42, this was exactly 2 minutes ago, Captain Jack Sparrow said there's a new artifact event, keptn sample, and it is 2.0, okay? What that internally actually did, it triggered my GitOps service, and actually, let me do this, let's quickly check this. What it should have done in my GitHub org, my GitOps service that is triggered by a keptn event, should have updated my YAML files 2 minutes ago, here it is, in my staging space. I know sometimes people are dropping things when they see this. This happens all the time. And the values YAML file should now automatically have been changed to 2.0. Right? And the only thing I told keptn is a new artifact. The GitOps service took it, updated it, and the GitOps service then also told keptn, hey, keptn, we changed the configuration. I changed the configuration, and so there's something new for you to deploy. What's her name? I'm not that big into Marvel. What's her name? Captain Marvel. So Captain Marvel tells me configuration change. You may wonder, why is it showing Marvel figures and it has no clue? One of my colleagues built this for me because we try to find as many captains as possible. When this configuration change is done, then I have a deployment service that is kicking in, and this captain I know, Captain Kirk, he then basically said, hey, deployment is now finished. Now you can do whatever you want, like testing. And deployment finished actually means, what should we see? If I go to my 2 frames, here we go. So now staging runs with build number 2. Production is still in a blue-green deployment mode in build number 1. Now the tests are getting executed, as you know, JMeter, and I think they run about 6 to 10 minutes. And then we should see, hopefully, a push to production or a failure, meaning not promoting. And I know build number 2 is going to fail, but I still want to wait it out. So, why did we build keptn? We built keptn because as Dynatrace, as a software company, and also talking with our clients that are in all sorts of industries, we have seen too many companies that thought, hey, we can just containerize an app and we put it on a platform and then we are cloud native. But that's not the way it works, right? I've been to a company actually I think I can say it, Vegas.com. They have containerized a 26 gigabyte WebSphere and tried to put it on a Kubernetes cluster, and now they thought they are cloud native. Well, they know they're not cloud native, right? Because it takes more than just putting something in a container and deploying it. So that's why the reason why we built keptn is, on the one side, we need to have, first of all, a change in mind. We need to make continuous delivery, but more importantly, continuous operations better, because it's still a big challenge. And to give you some numbers, I know that most of you are developers, and you may not care about these numbers, but hopefully they give you a little sense of what's actually happening in the industry. We talked with a large number of our users, and we had a survey. And we asked them multiple questions, but two of them were, show me what's your commit cycle time and what's your MTTR, mean time to repair in case something bad happens in production. And we asked them, please only answer for your cloud-native projects. And the result was that only about 5% of the people we surveyed are really deploying fast, and more importantly, they can also roll back fast or fix the problem fast. So that means we really still have a big ways to go. And we looked at this a little closer, why this is. There's different reasons behind it. So for instance, continuous delivery turned out to be a big problem. I'm using this to show something we have seen internally and also with our customers, right? We have a lot of tools, and I'm sure you know some of these logos. The problem is if you start building your own pipelines, you typically build a lot of custom integrations. You build it either in your Jenkins pipelines or in whatever tool you're using. You have a large custom code. Yeah? Who agrees with me on this? Yeah? I know it's hard. She's falling asleep almost. Almost, we're getting there. Now the problem is, at least in our organization, and I talked with a large automobile company in Germany, and they said, well, this is not true, because we do not have one team. We have about 50 teams around the world. They're all building their own different integrations, most of them the same, some a little different with different flavors, but we have a lot of engineering resources around the world that are just trying to keep our future legacy code floating, right? The quote came also from that company, pipelines seem to become our new future unmanageable legacy code. And this is the first problem we wanted to solve, because keptn does not need you to build any pipelines. The only thing you saw me do earlier with my Shipyard File is specify how many stages I have, what test strategy you want to enforce, and what deployment strategy you want to enforce. And the other thing you need to give us, obviously, the test files and how you want to evaluate your build through the perf spec, so that is available by Potometer. And if I want to replace a tool, if I want to add another tool, then I just need to tell keptn, from now on, I want this tool to handle deployments. I want to have this tool to handle tests, or this tool an additional, but I don't need to change any code. It's all through configuration. So that's the first problem that we solve. The second problem is, and I believe this is the one that is very hard, that's very important for us, because we know there are other tools out there that also try to solve the same things on the continuous delivery side. Jenkins Access has done a great job. GitLabs, Argo, there's a lot of continuous delivery tools out there that also try to fix the problems that are wrong right now with continuous delivery. But what they don't fix is the thing that comes after continuous delivery. And here's the analogy that I want to bring, because I really like the analogy, because it really hits the point. What you see here is a picture from NASA, right? And the way NASA operates, I didn't know it. I learned this from my boss, because he came up with the analogy. In NASA, they have two teams. There's one that is called launch control, and the other one is called mission control. Launch control is the team that is responsible for everything until the clock ticks down to 0, until the rockets lift off. Until that point, they can abort the mission at any time. They monitor all their stuff, and they can say, even 1 second before the liftoff, abort mission. And that's their job. That's launch control. And that's also, for me, continuous delivery. Continuous delivery means we have an artifact, and we can push it as long as we want, and we can stop it before it hits a significant amount of end users that might be impacted with a bad build. Okay? Once the thing hits 0, it switches over to mission control, a completely different team. And this team also has completely different responsibilities, because they cannot say after 10 seconds, we abort the mission, because the rocket is 10 seconds in the air. They have to deal with whatever comes, right? They have to get the rocket safely up to space and also back down again. And this is also where mission control, from our perspective, correlates with continuous operations. A quick question here. I know this is a majority developer audience, but is anybody here responsible for operations? Does anybody get triggered in case something goes wrong? A couple of people, right? It's not that fun when something goes wrong. So that's why, because it's not that fun, we wanted to optimize this as well. And this is why keptn has really been built with a couple of, let's say, core principles in mind. The first one on the left is automated multi-stage unbreakable pipelines. That's what we call it. That means these are continuous delivery pipelines that will stop before you deploy into production in case there's anything wrong, avoiding any issues, right, through the automated quality gates. We support blue, green, and canary deployments, but we don't want the developers to deal with figuring out how to correctly do blue, green, and canaries and how to do the traffic routing. We do this fully automatically. And it says self-healing here because if we detect that the blue, green deployment has a problem, if a canary has a problem, we automatically roll back and heal the system. And on the right side, we have event-driven runbook automation. That means if something is in production, in case it is in the hands of mission control and something goes wrong, we get the data from all the tools that are feeding data to keptn, and then keptn is executing the right remediation actions. Scaling up, scaling down, redirecting traffic. If we detect a bot attack, we turn on, we use Istio, for instance, to redirect the traffic, to block them. If we see there's a marketing campaign running really good, we can scale up, or we can roll back a feature flag in case we see there's a problem with the feature flag. Right? And this is why, if I overlay it, this is what kind of overlays with launch and mission control. Does this make sense? Yep. Okay. So there's also a lot of other things. As you have already seen, it's all GitOps based, or GitOps based. That means what really triggers a new workflow is a change in the configuration files that is then triggering the deployment. And it's also, we are basing the whole thing on Kubernetes and Knative. That means everything is event-driven. All the tools are pluggable. And yeah, I mean, the other things, we have the operator concept, and everything is as code for us. The monitoring, the quality gates, everything is configured as code. So before I go into the conceptual architecture, I got 14 minutes left. Let's see what happened. So, evaluation done, but nothing has been promoted further. Nothing has been promoted, or let's see. Nope. So, that means build number 2, made it only to staging, evaluation was done, it did not succeed. Let me just go in here quickly, because I also have my Dynatrace service enabled. So if I go to my environment, oops, what is wrong here? This is interesting. What is happening with my browser? Wow, completely crashed. Let's do this again. All right, transactions and services. So Dynatrace, show me my services in my staging environment. There's only one in here. And what I should see on the bottom, here we go. So keptn, we also have a, let me go to the last couple of hours. And so we also have an integration where keptn is also sending all the events that it sends to me on Slack. It's also sending it to me to Dynatrace, to the monitoring tool, so I actually know what is happening on this particular service. Right? And if I go back to the last 6 hours, you can see I ran a couple of tests, and I can see whether things went great or didn't went great, and what's happening. The performance test succeeded. What I'm expecting to see as a next event is not promoted because the Potometer Core was below 75. That should also show up here. Control-5, let's try this. Should show up here in a second or two. But that's why it's not being promoted to the next phase. Let me kick off build number 3, because build number 3 should go all the way through. or actually because of only 12 minutes left, let me do build number 4. Because build number 4 will also make it all the way through, but then it should actually trigger a problem because there's an issue that, that happens in production only that was not covered by the tests. Okay? Good. Conceptual architecture, as I mentioned earlier, keptn as its core is using Knative, top right. All the individual services are Knative services. We have different categories. You can see some of those with a solid blue background, like Git, like Docker, like Jenkins, Potometer, ServiceNow, JMeter. They are all already implemented and part of the current keptn release. Those that are kind of in a little shade, they are on our short list, but there's many more that we plan. The idea is that when you install keptn, you actually tell keptn what type of tools you want. We call this the uniform, right? Like a keptn wears a uniform. And what keptn then does, it will automatically install those integrations of the tools that you really want to use in your project. It installs it and it is connecting it with the Knative events. And the second thing you have to do is, you saw my Shipyard file earlier. In this example, it shows 3 stages. If I have a 3-stage Shipyard pipeline specified, it would automatically create dev, staging, and production namespaces in Kubernetes, will automatically configure Istio correctly for traffic control depending on the deployment strategy. Okay? So, to give you a little more details, this is really how it looks like. There's a CLI, keptn, where uniform, and this is what the uniform file is, a shorter version of it, but looks like. You basically say, hey, keptn, I want to use the Docker Hub, the Jenkins service. The Jenkins service should be triggered when a new artifact comes in, a deployment is finished, and I want to have my Slack service. And then keptn will automatically make sure that all of these tools are installed and properly configured. And then my uniform, my Shipyard file. This is the Shipyard file that you saw earlier in a JSON format. This is not a YAML version of it, where I said I have a staging stage with direct deployment, performance test strategy, and production is blue-green. And then keptn will automatically make sure that the correct namespaces are created and that also the configuration is stored in Git. And you saw this earlier in my demo. Now the cool thing with this is you can also update your tooling and your pipeline. So for instance, one of the problems we wanted to solve, what if you want to use a new tool? What if you have a requirement that you need to include monitoring? What if you have a requirement that you need to include a security check tool? What if you have a requirement to include a new testing tool? You don't need to change any pipeline code anymore. The only thing you need to do is keptn update uniform. And then keptn will just install these Knative services, and from now on, they will be called and triggered when you push a new artifact through. And the same works with the pipelines. What if your company is now required, because of policy, to add an additional security stage where you do say your security testing? You basically say, keptn, update my Shipyard file. And from now on, the next artifact you push will be pushed through a new additional stage. And obviously, obviously all of this will also be reflected in Git. So the GitHub repository will automatically be updated for you. Okay? Who in here is responsible for keeping pipelines up to date and doing continuous delivery and continuous integration? Yeah? Does this solve any problem for you? No. We need to talk, because then we're building the wrong thing. Does this solve any problem for anybody? Yes. At least we have a fight later with her. But I'm seriously interested in what you're doing and why you think this is not necessary. Okay, so updating the tooling. What is happening behind the scenes as I was pushing through the builds? Let me just double check what's happening now. Oh yeah, here we go. So configuration change, keptn check, Sparrow told me about a new artifact, and also the configuration change event already came in for build number 4. So that is running now. I should soon see the deployment being reflected here. Probably still, here we go. Build number 4 is already deployed. Now the tests are running, and I expect build number 4 to be all the way promoted to production. So what happens behind the scenes? Remember, new artifact event, keptn gets the event, it's all using cloud native events. That means what keptn uses is knative. There's a pub subsystem, and that means I have, in my case, my Slack service listening to most of the events and also my Dynatrace service. So that means I get this information. The next thing that keptn does, it says, hey, I have a new artifact, so please, somebody updates my config. We saw it earlier, GitHub is doing this for me. Then keptn knows, based on the Shipyard file, the first thing is I need to make a deployment. In my case, I'm actually using a Jenkins pipeline to do the deployment. So Jenkins deploys it for me. Then it's executing the tests. I have another Jenkins pipeline actually that executes the JMeter tests for me. And then at the end, it does an evaluation where Potometer comes in. And you've seen this before. If everything is good, keptn says, we got enough points. Let's tell whoever can deal with it that we want to update the config to build number 2 in production. So GitHub will update it, does a blue-green deployment, does an evaluation. I don't have a test strategy specified here. An evaluation still makes sense. I may want to evaluate if after the deployment I have, for instance, if my conversion rates go up or down, or my user experience, or my performance is bad. Then if this is not good, then it will automatically roll back. And if it's good, then we kind of hand it over to mission control. I call it here no ops to freak out some of the ops people in the room. There's still ops. But in case there is a problem later on, then you've seen it, then the monitoring tool can send a problem to keptn, and then keptn will execute, for instance, will tell me about it in the Slack channel. I can trigger an Ansible script. I can trigger any type of auto remediation script. I can trigger ServiceNow with integrations here already. So this is then the idea, and then it kind of flips back blue and green. Okay? Good. I have one last thing, because while keptn, I love keptn, but one part of keptn I love even more, it's Potometer. And the reason why I want to talk about Potometer, because Potometer can also be used standalone. In case you cannot use keptn, but you want to use this evaluation between the stages. So what is Potometer? It's a standalone library that you can just download from GitHub. It has 2 major concepts. On the one side, data sources, and on the other side, graders, right? Data sources, we have Dynatrace, Prometheus, Nearload is building it. Again, whatever other monitoring tool or other tool that can provide data will integrate. And then we have different graders. We have a threshold grader, a baseline grader. There's a grader that one of the German companies, T-Systems, is building with a smarter baseline algorithm. But the idea is you give it the file that you saw earlier, right? And in this case, we can see here there is a Prometheus data source for average GC duration with thresholds and so on and so forth. And the second one is a Dynatrace metric. So the idea is that you specify what type of metric you want to evaluate and which data source is providing it. You specify the grading details and the score, and then at the very end, the total scoring objective, right? You saw this earlier in the demo. So the way this works, and I think you also saw it, or I tried to explain it, but now visually. So for instance, if Potometer is for the Prometheus metric returning a certain value, and in the threshold would be 2 gigabytes. That means everything above 2 gigabytes is 0 points. Everything below, because there's no warning, would get the full 20 points. If the value would be 3 gigabytes, 0 score. And the same is then repeated for any other metric. So for conversion goal, here we have specified 2 and 5% and 20% max. That means if the value would be 3.9, it's exactly in the middle, then you would get 10 points. Right? And then you get a total score, and then depending on the objective, it's good or not good. Now the good news is you can also use this standalone. As I said, it's just a Node.js set of Node.js libraries. There's a blog post out there, and also on the Potometer GitHub page, we have all the instructions. So you initialize it, you specify your data sources with your credentials, because some monitoring tools obviously need API tokens. You specify which grader you want to use, and then you run it, and at the end, what's getting spit out is a result file that basically says which values came back, and did it breach any of your thresholds, and what's the total score. right? It's all here. Right, perfect. This is just an additional feature for Dynatrace. In case you're using Dynatrace, we also have the capability to not only monitor metrics like response time thresholds or response time on memory, but you can also monitor dependencies. So for instance, you can figure out how many dependencies does one microservice have to other services in the backend. And then you can say if this microservice, after a code change, has more than 2 dependencies, because it should only talk to this and the other service, then it should fail. So we have additional metrics, incoming calls, outgoing calls, and also on how much pods you run. And you can also specify this in the Potometer file. And the last on Potometer, that's coming in July, I'm doing the pull request next week. We will have a threshold or a grader where you can actually then compare with the previous build, and you can specify percentages. And then what you will get is also, again, I'm not good in colors and also not good in UI, but it's my first throw. So you will get a UI on top of Potometer, because all the data gets stored in the MongoDB. And then for every single run, on the top you see the score. Green means I had enough points. And then on the bottom you see the actual value for every run. And then also the calculated thresholds by looking back at a referenceable build. Right, so this all works, hopefully. And it should be, something that you can use as standalone. All right, there's a lot of other stuff that is coming, but because I only have 50 seconds left, I want to leave you with this slide here. If you are interested, then join the community. Do me a favor, on the community, there's also an invitation to our Slack channel. You can, please do me a favor, also follow us on Twitter. If we build something that has no value for you, I'm still interested, because then we at least know in which direction we are maybe overlapping with something that already exists, right? Maybe that's the reason. If you think there's something that is cool but needs additional stuff, just join us, put issues into GitHub. And we also have bi-weekly community meetings. You can join us live every other Monday at 4 o'clock in the afternoon using this Zoom link, and then all of the meeting notes, including the links to the recordings, are also here. And having that said, I'm not sure how far my deployment went. It's still running, but I'll keep this open, and because I'm out of time. But I will be staying here for a couple more minutes, or you can find me at the Dynatrace booth. Okay, thank you.